Friends, next we discuss the process of detection and estimation in digital communication system. For this, we consider a simple block diagram of the digital communication system. Here the first block is message source, which provide a discrete message in the form of symbol, and it is represented by M suffix I. This discrete message is first passed through the transmitter where the encoding and modulation process takes place. Here the signal transmitter encoder convert discrete message Mi into a sequence of set of real number in the form of symbol vector. After encoding, this vector sequence get converted into signal which is compatible for transmission purpose and having some finite energy. During transmission, additive white Gaussian noise denoted by W function T is introduced with information called as received signal X function T. This received signal again get converted into observation vector denoted by capital X vector, which further decoded and we get the estimation symbol represented by M cap. Now we explain each block in detail. Initially, message source, which contains capital M number of symbols, emits one symbol at a time, that is symbol per t second. These discrete messages are called M-array output, with each discrete message having corresponding probabilities p function m1, p function m2 up to p function m suffix m. That is called priori probabilities. Also, when all discrete messages are of equally likely, then the probability of M-array output message is 1 upon capital M, that is for all values of I. Now, the M-array output, that is M suffix I, is passed through vector transmitter, which is a type of signal transmission encoder which encodes M-array output into a sequence of n numbers, that is a set of n real number and having a dimension capital N less than or equals to capital M, which means at the input side we have M-array output, and after converting into a sequence that is of n dimension, we get a set of n real number, and here the output having a dimension n that is less than or equals to capital M. For example, we consider M-array discrete message denoted by Mi, that is in the form of sequence, that is M1, M2 up to M suffix capital M. Now vector transmitter encode each symbol Mi into a set of n real number and called as signal vector denoted by S suffix I vector. This Si vector is also a sequence of Sn vector, S2 vector up to Sm vector, and each vector has n dimension which must be less than or equals to capital M. Now in the transmitter itself, modulator convert the vector sequence Si vector into a sequence of finite energy signal and is a function of time t called as Si function t, which is equals to sequence S1 function t, S2 function t up to Sm function t, that corresponding to the continuous finite energy signal over a symbol duration of t greater or equals to 0, less than or equals to capital T. Now, as the modulated signal, that is Si function t, is necessary to be a real value energy signal, and it is represented by expression Ei equals to integration Si function t square into dt, taking integration limit 0 to capital T, and for I equals to 1 to capital M. Now during transmission through the channel, only one signal of Ei is transmitted per t second, and here we consider a linear channel with sufficiently large bandwidth, so the transmitted signal Si function t get added with the noise Wt called as additive white Gaussian noise, which having a zero mean and power spectral density of n0 by 2. Now at the receiver side, the received signal x function t contains two additive terms, that is SI function t and WT, that is over a time interval of t greater or equals to 0 less than or equals to capital T and for I equals to 1 to capital M. Next, at the input of the receiver, x function t signal is received as one symbol within duration of t second. So first, detector converts individual symbol into corresponding observation vector denoted by capital X vector, and then a signal transmission decoder again transform observation vector into the estimated symbol M cap. This signal transmission decoder is a type of vector receiver. So this combination at the receiver make a decision and compute the estimated symbol M cap, that is corresponding to the symbol which was transmitted. And the decision at the receiver is totally based on the priori probability of signal vector sequence denoted by SI vector. As this signal vector consists of sequence Sn vector, S2 vector up to Sm vector, which corresponding to the individual message symbol M1, M2 up to M suffix M respectively. Now, in order to make a decision, priori probability of M array symbol makes possibility to make decision and estimate the output symbol M cap. But while detection and estimation in digital communication system, additive white Gaussian noise affect the decision making process and give rise to a symbol error. And our purpose is to minimize this type of symbol error. For this, we use an optimum detection process where optimum receiver is used to minimize average probability of symbol error. So there are basically two types of optimum receiver, that is based on coherent detection and non-coherent detection. At coherent detector, the receiver must be synchronized in phase with the carrier at the transmitter side, while in case of non-coherent detector there is no requirement of phase synchronization.